Hello.
Hello together.
Hello.
Hi, Robert. Hello, audience.
Yeah,
We are back to a next episode of Fun with RELUX.
Yep. This episode is about daylight.
Yeah.
We have two episodes about daylight. This is the first episode. There will be an episode after the next episode. So in August, there will be an episode about daylight efficiency, efficiency in terms of power usage, power consumption. This episode is about the fundamentals, the basics about daylight calculation, of course, in connection with RELUX Desktop, but also what is about daylight, what can you calculate, what are these values, what kind of standards are existing, and so on. So this is some kind of introducing into the daylight for a lighting designer. Yeah, there is one standard in the European Union or in the area of CEN countries. This is the EN 17037. This is since 2018 an European standard for daylight calculation and daylight usage. And before 2018, there was no European standards. There was just national standards. So in Germany, we had our national daylight standard with a daylight factor, and now we have an European one, which is quite intense. In the standard, you have to have certain values for a daylight factor and daylight usage of rooms. So you have to have a specific daylight factor. You have to have a specific duration of sun impact to the room. You have to have a specific glare ratio of it, and you have to have an outlook of the windows in a certain way. So this is about the standard. It's wise to check the standard if you are going deeper down in daylight. But yeah, if you just use it once a while, then of course you can live with what you found in RELUX Desktop. Yeah, and today we want to show you what is about in RELUX Desktop, what you can calculate, and how you could set the stuff in RELUX Desktop.
Yes, daylight is a very complex field, and so in our actual format, we can just give you some ideas and where you will find this in RELUX. Especially, we have two kind of calculation kernels, and there is a much big difference between, especially when we are talking about daylighting, between our standard calculation kernel, the radiosity, against the alternative calculation kernel, the ray tracing. And with ray tracing, we have also the possibility to calculate complex materials, especially in glass materials in the transparency, and which are not possible with the radiosity method. There is something there we have for the interior, as you know, is just with diffuse surfaces, and similar we have for glasses just a transparency, not a redirection of the light or the diffuse and complex materials.
Chromatic effects.
Whatever. There are a lot of stuff breaking inside of the glass or of the transparent material.
Yeah.
Okay, so should we take a look to?
We should take a look into what is possible in RELUX. So we share the screen, and you should see now an open Windows desktop.
Yes, and here we will have a simple scene
without any luminance. So it's just in daylight, 100% daylight scene. The first which you might notice is that there are windows in it. So it's just possible to calculate daylight with windows. So even if you search for daylight calculation stuff in RELUX, if you don't have a window inside, then it's hard to find these options.
So that will not be the big effect when you try to make insert. For placing windows, you will find them here in the insert ribbon and room objects, and there you have various styles of windows. You have also the possibility to draw your own but let me place a standard window. And there's one point. You can use windows by dragging them to a wall to place them into the wall. We'll switch to the 3D. This was this window. But we have also the possibility to, to place it in the ceiling, and in that case, we will have a
rooftop window.
A rooftop window, a skylight, which can be placed in your scene, in your room. I will now remove them again. For the materials, as I know, we will later show you a little bit how you can choose other materials. We have at the moment just default glass material. And in this case, this is transparency. That means that 80% of the light outside will go through the window inside of the room. And also interesting when we are working here, especially for daylight, but sometimes also for interior lighting, for artificial lighting, is we have the possibility what we are actually see is an interior view. That means we are looking all the time inside of the room, even if we are outside of the room. And by switching to the there's just nothing should be selected in this situation, and then we can switch to the exterior view. And now we will see the building from the outside, from the perspective of the daylight, which goes inside to the room. And here we will have the possibility also to place obstacles for shadowing, for example, to simulate a building or something like that. We will simply place a cube.
And you should do this because it has an effect on the daylight calculation. So obstacles or facades in the streets has a more or less big impact in your daylight calculation. So yeah, this is needed that you have all the obstacles, all the trees, all the facades from the opposite of the street with modeled in a way that you have with the right reflection degrees, and also mind about the color of the floor. So this has also an impact on the daylight calculation inside the room. So the complete scenery of outside has an impact for this. So this might be in interest and might be handled and managed in a way to have this information in it.
Yes, and also maybe at that point here, at that point when we click, for example, for the floor, you will find here that we have here the interior face. This is the reflection degree of our floor when we are inside of the room, and the exterior face is the screen surrounding, which will have an effect to the daylight, and we will also see it here in this exterior view. Okay, when we make this calculation, that's the next point. That we go switch. I will remove this from my first calculation and switch off the exterior. And then when we go to the calculation, and then here we will have the possibilities to switch on. Actually, the daylight is active because we have just a room without luminaires. There are just windows in it. If I have both, then I have also all three options available. So I can choose between artificial light, daylight, and or a mix between daylight and artificial light.
Yeah, you get results in output for daylight, for artificial in separately. So it's just about the duration of calculation. If you have both selected, then you get a longer calculation time, but you get more results in the end. So this is here to choose what you want to calculate.
Yeah, and there is one other thing we have not explained at the moment. When we are making daylight, it is also important that we have set the correct parameters for the room and
the orientation for
the orientation and the location of the room. And for that, we will find here in the project, you will find here the location button. And here you can choose between some important cities in Europe. I guess mostly in Europe, yeah, we have also Sydney and so on. But you have also the possibility to put in your own location by defining to set here the longitude and the latitude of the place where you are. You have here also the possibility to set the time zone and the settings for the time zones, because the calculation, the daylight calculation, is mostly founded to for the calculation of the true local time. Sorry, I have forgotten the English name, the correct spelling. In German, it is die wahre Ortszeit.
Yeah.
And that means that is the time which is defined by when the sun is in the highest point. Then it is 12 o'clock in the
yeah. Because the sky models have just let's say, a peak of the sun, and this is about 12 o'clock for our internal, let's say, WOZ zone, which is some kind in English of the truth of the time, yes. The truth time zone, which means is accordingly the sun. Yeah. So in sun-oriented time zone. Yeah.
And in later in the calculation, we will set the date and the daytime when the calculation is running, and this will be then converted to the true local time, which for the place where we make the calculation. Okay, this is the location of our room, of our scene, and the second one is the north angle. By default, this is here upward, north is upward, and you can change it by clicking here in the properties of the room. Sorry, here of the room, and here in the down here you will find the north angle. There is one important thing in RELUX. Typically, the rotations are mathematical positive. That means a positive rotation is against the clock. And the north angle is different. So this is related to the definition in the most papers of the north angle. And so a north angle of 45 degrees, for example, will change here to the direction northeast. So related to the original orientation, it is now to the northeast of the things. But the north angle will be opposite counter than the typical rotation in RELUX.
If you're confused, just check this north symbol, this north icon, and then you can see this is the north direction. Makes sense not to just to relate to the angle. Just have a look on the orientation. This helps a lot. Yeah, and this is of course important for the sun, especially if you are more in north or more in south of the globe. Then the north angle has a big impact. If you are on the equator in the middle of the Earth, then yeah, okay, it's not this big, depending. But yeah, so this is has to be also set it if you're doing data calculations.
Yeah. Okay, and then we have here in the calculation button, and we will now check to the calculation manager, where we find all the additional settings. Here we have the possibility, if we place luminaires inside of the room, we have here the possibility also to choose between the 3 calculation options. It is actually not possible to run both together. You must run them sequentially when you want to make both, or make a copy of your scene and use one for the artificial light and for the daylight.
Yeah.
And when we click on the daylight, and we will take a look here to the settings, so the top upper part, this is the same as we know it from the artificial lighting. And here, one of the most important thing is here to choose the correct sky. And here we have actually 3 sky models for the radiosity method, which is the overcast sky, the clear sky, and the clear sky with sun. And only the overcast sky is useful for the calculation of the daylight factor, because only for this sky the daylight factor is defined.
Yeah.
And you must imagine that the overcast sky, this is a cloudy gray sky with a
diffuse light.
With a diffuse light on the sky. Okay, the next thing is that we have to choose here the date for the day we want to make the calculation, as well as the daytime. And here you will, so I don't remember what is this TSD.
It's through sun time.
Through sun time, maybe it's through sun time. I guess it's through sun time. Here for this location here, Basel, and with the settings. Okay, then everything is the same. We press start, the calculation starts, and it needs a little bit more time than the typical artificial calculation. We have here very simple calculation. And when we take a look to our output bar, result overview, we will find now two result overviews. This is only because we have used this overcast sky. So we have also here the possibility to get an overview about the daylight factor, the daylight ratio. And here this is the classical. You will see it's just the illuminances. And here in the results, we have also for the tables an additional category, daylight factor, where we can take a look to the daylight factor as numbers in the table, as you know it. And also we have here for the pseudo colors, we have a daylight factor for this horizontal areas where we can see the daylight factor as a, let's say, as a false color picture. And you will see there is a much more dynamic, as we will have typically this for artificial light. And here is also one very interesting thing, because some of the planners needs a relation to the procental part of the complete surface, which we have more than 10% daylight factor on, as much at 10% of the surface, for example. And we have in the past, there was an output which is called Energy 2000, who has this output defined, but this Energy 2000 will not longer be used. But we have here put properties. In the properties, you will find here the option to show the distribution in percent and in area, for example. We can also limit this to only to the used levels. And then we will have here inside of our case gray color the factors. So for example, here in this example, now we have for the daylight factor about above 12% is also between 12 and 20% is on 30% of the surface, which means this is approximately 6 square meters of the total surface we have here inside our room.
So the fraction of the room size, split it down to the areas of the daylight factors. So for some standards, for some let's say interests, this is interesting to have this portions of this coverage of daylight. Yeah.
This works not only for the daylight factor, this works also for illuminances. So maybe it will be helpful also maybe in some artificial light calculations.
Mm-hmm.
Okay, this is about the standard calculation. There is one new option. We have just implemented a short time. This is about the glare.
The glare. It's also some point in the European standards 17037. This is a new calculation point. I go here back down to 2D and I just insert this daylight glaring point. This is called DGP. It stands for daylight glare probability. So we can calculate here a probability of the glaring for a specific point for a specific direction. So I will set here an observer and here one observer, and I will rotate one of these observers maybe more to a window. So let's see if we have a big effect on it, and then you can just do the same calculation of it, and you will get daylight glare probabilities. This is some kind of UGR. So if you know what a UGR is, this is some kind of UGR for windows or UGR for daylight impacts. And we can see here this 2 points. It's also still a very low daylight glare probability. We have here a 0.24 and a 0.28 for this both. This point had a bit of more daylight impact. Yeah, depending also on the orientation of the complete room, of course, and the impact. And you have also some kind of legend, because this factor is maybe a bit of new, maybe not just to you, maybe also to your clients or to the reader of this sheet. So we printed here the legend out of this EN 17037. These are the, let's say, the range of the daylight probabilities. And if you have very low, there's not really big impact. If you have very high, you might need to install some daylight shadowing systems or some preventions, or maybe you need to rotate the desk or do something in order to have the observer in less windows coverage in daytime, so to speak. This is a new factor which we have planted in also 2 or 3 years ago. So it's also not brand new, but in relation to the complete time of the RELUX desktops, this is a kind of new element we have. Yeah, and then we have also the, I don't know if you want to go deeper with this red tracing options.
Yes, we want just show you that we have what we have shown actually is the standard, and using the standard calculation kernel for evaluating the daylight factor. You can also use other sky models in the radiosity, but we have also our alternative calculation kernel, the ray tracing. And there we have some more sky models in it. And we have especially there are very deep parameters for many not for many, but for controlling this kind of calculation here, especially in the ray tracing. And the most special thing for the ray tracing is also able to use functional materials. And for that, we can go to the material selection. And add. And there we will find in the ray tracing materials, and when we go to material types, and when we then there click to class, we have here specific classes which are already prepared for terminal protection glazing, and or if you go to the class other, the option on the left side. Here. Yes, there we will find, for example, like a Milky class or structured class. And so with this calculation kernel, you will have also the possibility to make really complex calculations with not only with this kind of clear class, which have also spectral effects inside for the calculation. But this goes a little bit too deep here. Please inform yourself here on relux.com in our tutorials and in our online help.
Yep.
And also, if you there have specific questions, please send it directly to support@relux.com.
Yep.
And we will try to help you.
Okay. Yeah, this is all what we want to show you about. Or maybe one we have also one presentation for one slide left for the
sorry,
so
yes, we forgot.
Maybe this is
yes,
something for the beginning.
Yes,
we wanted just to inform you or to tell you what is the daylight factor involved.
Yes, sorry.
There's one kind of definition. This looks a bit of complicated, but it's quite simple. So really, in the end, it's about the light, the illumination of the room with and without the room. The factor between these two parts. In short,
this is just the ratio between the interior, the illuminance inside of the room, divided by the illuminance outside of the room, which is anywhere out there, and because we have a diffuse sky, the overcast sky, so we can say that everywhere around the room is the same. It's the same exterior surface, and so this is the calculation of the form. And also, it is a point that the summary of the interior illuminance is the summary of the direct part, which comes directly. This is DA, or this is EP, which comes directly from the sky. We have a part which is reflected by exterior, for example, for a facade, which is on the opposite side from my window. Also, it is not seen here from the, it may be also reflected from the ground to the ceiling and back to the reference plane. And we have the distribution, which is inside of the room. So let's say the kind of the indirect part inside of the room.
Yeah, so really everything what happens to this point with the room in comparison to outside on the same spot. and yeah, this is the quite simple ratio. This is something which is easy to impress or easy to have in mind what it means if you have 5% or 20% or just 1%, so you know, okay, just 1% comparison with outdoor. So they have maybe too much concrete around the points. Yeah, this is something what we wanted to tell in the beginning, but
yes, we missed it. We missed it anywhere in the middle. Sorry.
Yeah. No problem. Also, there's something we want to show you. This is a website. This is this website. Yeah, just go to the start. There's a website called, you can also see it here, I guess. No, here we have in large. The website is called aboutdaylight.org. This is a website created from, let's say, professors or from university colleagues from Daylight, so Daylight experts from universities from Germany, Switzerland, I guess also Austria. Yeah.
There's here.
Is it still English? Yeah,
yes,
it's available in German and English.
That's the.
This is English, yeah.
Yes, this.
And this is a quite simple website.
No, but here this is just in German.
Okay.
No.
Okay.
Here,
right.
it's both, but it's on the safe side. And it's here. So what is bad?
Okay. And this website is in good entering in Daylight. So this website is quite simple. It's like a brochure, like in paper, but published as a website, so it's easy to access, easy to share, and it's quite simple. There are 24, if I remember right, 24 theses about Daylight, and you have this thesis, let's say short articles about Daylight arranged on these tiles, and if you click on one, you get some information about a specific aspect about Daylight. So this is more let's say an information point, things to think about, to getting deeper down into the specific aspects about Daylight, and helps you a lot if you are beginning with Daylight to keep everything together, not to forget something, and also to investigate deeper into this. And also it's a nice tool to share this knowledge, to communicate, to tell your clients this is about Daylight. It's not just about I can save energy. There's clearing. There's a lot of aspects which is covered here in a way. So we want to just to inform you about this. This is non-profit, non-commercial, just a simple publication from professors from universities dealing with Daylight for the public.
Perhaps we're in, let's say, in love with Daylight and very active in this community. And they may decide, and we want to recommend it that you can take a look to this site.
Good. Then we can go to the questions.
Let's take a look to the questions, and
so we can stop the sharing here. We have to open the questionnaire. This is here. Okay. Okay, as it don't seems that we have a question, not even a test question, but maybe I'm doing something wrong with the sheet, but I don't think so. feel free to ask us questions if you have questions about daylight. If not, it's also fine. We know that it's a quite special topic, which is, yeah, bit of special, not for all of the community. We also check the chat. Nothing in the chat. Ah, there's one. Okay, so it's just a test question. So technical, it works.
So we have no problem.
Yeah.
Okay, so then we hopefully hope that everything is clear and that you also that you already enjoyed this episode.
Yeah. If you want to dig deeper, we have in 2 episodes. We have also daylight again, but from an efficiency point of view.
Also a little bit more on the sunny side of daylighting. For example,
the sun altitude diagram,
sun altitude diagram, and these points.
Yeah.
But I guess in the next episode we have, so daylight is also a little bit old stuff because we have daylight in our program all the time. But there is one question now coming in. What is the best way to set up and draw the building? Can the model be used for daylight and artificial light calculation? Yes, of course. Yes.
Both in the same model.
In training, I have seen that we are at the sensor for the calculation of daylight. Is this still the case? Yes, but this is then the point which we have in the next episode, not the next episode,
the next episode.
The next episode, when we are talking about efficiency and what we will use this kind of calculation. For example, you have when you want to try to calculate the efficiency of daylight, when you are using daylight sensors, you need to know what is the impact of the daylight, and that is what we are calculating when we make calculations of the daylight factor and what we have seen today.
Yeah.
But this is also next time we will have some very new, totally new feature in RELUX.
Yeah. We show you on the 20th of July. This is in about 1 month, 20th of July. We have our episode 24, and this episode is about room scanning. So we have, together with a partner, a nice tool for mobile phones or tablets, where you can screen scan your room and get the geometry of the room, including furnitures, later on also including the luminaires inside, and RELUX project file, which you can then use in RELUX desktops. This is a really new feature, not just of RELUX, but also from a specific app which we partner. And this is something we want to show you in the next episode and demonstrate what you can do with this technology and how it feels and looks and works in the next episode. So that's all of it. Thanks for the last questions. So now it's coming some questions in, but this is for next time. Thanks for the questions. See you next time, 20th of July with the next. If you want to see this episode again on YouTube and on our website, you find all the episodes of Fun with RELUX. Then have a nice time. See you.
Enjoy the summer.
Bye.